Hello, today is Saturday, January 6th, 2023. I am resting at my place in Tuandong, and I am lying on bed with my belly. And I am trying to read this article to practice English. And also, I would like to know how they are going to increase the accuracy of the GPS system and what technologies are involved. So here we go. This article is from Interesting Engineering. And here we go again. A navigation system has been created that is more accurate than GPS. The new alternative positioning system could achieve an accuracy of 10 centimeters. By Brittany Grimes, November 18th, 2023, 3-minute read. Researchers have created an alternative positioning system that is more accurate and robust than GPS. The team discovered that the alternative positioning system is more accurate within urban settings. The prototype that demonstrated this new mobile network infrastructure was able to achieve an accuracy of 10 centimeters. The results from the study were published in the journal Nature. The novel system uses mobile telecommunication rather than satellites. The researchers from Delft University of Technology, Vrije University, Tite Amsterdam, and the VSL developed an alternative positioning system that uses mobile telecommunication rather than satellites, which could potentially make it more accurate and reliable than GPS. We realized that with a few cutting-edge innovations, the telecommunication network could be transformed into a very accurate alternative positioning system that is independent of GPS, said Joran Kloremeij of Vrije University Tite Amsterdam. The team succeeded in developing a system that can provide connectivity similar to mobile and Wi-Fi networks. It also has accurate positioning and time distribution. The new system can be used in a wide range of applications, including automated vehicles and next-generation vehicle communication systems. Improving the accuracy of the new system, the research team realized that weak radio signals relying on satellites can make GPS inaccurate. If the radio signals are reflected or blocked by buildings, then they can no longer send over accurate positioning and information. This can make GPS unreliable in urban settings, for instance. And Christian Tiberius of Delft University of Technology and coordinator of the project. He mentioned another big issue involving the future of autonomous vehicles, which cannot function off of unpredictable GPS positioning. Also, citizens and our authorities actually depend on GPS for many location-based applications and navigation devices. Furthermore, so far we had no backup system. Tiberius continued. The new system can act as an optional system or maybe in the future a potential novel replacement for GPS. SuperGPS. Currently, many people use GPS United States and Galileo European Union for navigation, but utilizing satellite systems could prove to be faulty at times. The new project started by the researchers is called SuperGPS, and its goal is to create an alternative positioning system using the mobile telecommunication network instead of satellites. The study has shown it to be more accurate than GPS. GPS. Innovative method. The research team created a process that would connect the mobile network to an accurate atomic clock so it can broadcast times messages for positioning similar to GPS satellites. The connections are made through the current fiber optic network. The team had already been researching various techniques to distribute national time produced by the atomic clocks to users throughout the telecommunication network. With these techniques, we can turn the network into a nationwide distributed atomic clock with many new applications such as very accurate positioning through mobile networks, said Eric Diericks of VSL. He mentioned that using the hybrid optical wireless system could give anyone access to the national time produced. It basically forms an extremely accurate radio clock that is good to 1/1,000,000th of a second. Diericks continued. Radio signals. The new system also uses radio signals with a much larger bandwidth than the software generally used. Since most buildings reflect radio signals, it can often cause confusion for the navigation device. The large bandwidth of our system helps sorting out these confusing signal reflections and enables higher positioning accuracy, said Gerard Jensen of Delft University of Technology. However, the bandwidth used within radio spectrums can be expensive due to its scarcity. In order to avoid a high expense, the team uses a number of related small bandwidth radio signals that can be spread over a much larger virtual bandwidth. This process is advantageous because only a small portion of the virtual bandwidth is used, and the signals are very similar to those in mobile phones. I don't know what they are talking about. I'll just stop here and come back later by listening to my own recording. Thanks for listening, and talk to you later.